let me know. 2 down, 2 unit exams, and a final to go. I'm pretty sure we're ready for this, I think. I think we finished up our last. Oh, okay. I was like, wow, I just see a bunch of blanks. I think this will work okay. Did everybody get one? So why are, I think we'll go around the room. That works in all of my classes pretty well. That puts everybody on the spot. Starting with Kate. So, first letter G. Why, here's the sun. Why do planets stick around? Gravity. So that's it. That's it. All about gravity. Yep. Gravitationally attracting. First one. All right. So, yeah. What is the planet that's closest to the sun? It is Mercury. Mercury. Dun dun dun. Well, let's just go around the room. So what's after Mercury then, Mackenzie? Venus. It is Venus. And what's after Venus? Yes, Earth. It is Earth. What's after the Earth?
Mars.
Yes, it is Mars. And then what's after Mars? Starts with J.
Jupiter.
Jupiter. Very good. And what's after Jupiter? Saturn. What's after Saturn? I get it mixed up.
Uranus.
It is Uranus. Very good. And then what's after Uranus? Those are N.
Neptune.
Neptune. And then what is after Neptune starts with the letter P? It is Pluto. But is Pluto a planet? No. Very good. So Mercury, Venus. Venus is about the size of. Well, I can't ask this. Actually, Earth. Venus is about the size of Earth. And so Venus is kind of more our sister planet. We think of Mars as being our sister planet, but Mars is they're a bit smaller than Earth. Let's see. So, what do you think? There's a word here. Now, water can be in 3 phases. It can be a solid, liquid, or gas. And what word goes there, do you think, Ashley? Earth is the only planet that has which of those forms?
Liquid.
Liquid. Very good. Earth is the only planet that has liquid water. You got it. Oops. I bet Kate might remember that. A couple of students have taken astronomy, which I encourage everybody to take in the fall. But Mars has 2 moons. Okay, so Kate, how many moons does the Earth have?
1.
It has 1 moon. Mars has 2 moons. And I don't know if you can infer this, but the other 2 planets we've talked about so far were what? Mercury and Venus? No moons. 0 moons. But wait till you see the Martian moons. They are just, they look like potatoes. You're like, are they cool or are they not cool? Well, they're probably not cool. They look like potatoes. Okay. And somebody told me after Mars is Jupiter. Oh, after Mars is Jupiter. But between Mars and Jupiter is this, the asteroid belt. And I think we might have the other day actually represented the asteroid belt in the hallway there. I'm not sure. The asteroid belt. Pluto is not a planet anymore. You're right, it's not a planet anymore. But Pluto is a dwarf planet. So it's almost like we came, well, it wasn't new. Was it new? I don't know. But we demoted Pluto to a dwarf planet, and we promoted Ceres to a dwarf planet. So actually, we got a dwarf planet that is actually, what makes it a dwarf planet? Well, what makes it a dwarf planet? Must be a certain size. Okay, must be a certain size. The reason Pluto, I'll just get to it right away. the reason Pluto, that's the sun, Pluto's way out here. The reason Pluto was demoted, honestly, is because if you look at how it orbits the sun, it's still got stuff there. It's still got crumblies. Okay, it did not clear its orbit. Okay, Neptune cleared its orbit. Uranus cleared its orbit. Saturn cleared its orbit. Jupiter cleared its orbit. Okay, Pluto, and honestly, the fact it didn't clear its orbit is one thing, and so if you kind of take that to the next step, what's going to happen is we're going to actually, as telescopes get better and astronomers start probing, we're going to actually find other things out here, and we have, that are as big or bigger than Pluto. And then we become like, okay, so Pluto's a planet. Then this is a planet, 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 and it just gets out of hand. Okay, so it's almost like change the classification of Pluto or else take in a gazillion other planets, planets. So yeah, okay, so somebody told me Jupiter. I know, well, you probably won't know the answer to this one. But you've probably heard of Galileo, Galilei. We'll talk a little bit, I think. I can't remember how much. I had to pare down the information, kind of history behind astronomy. But if you think of Galileo kind of looking at the heavens through his telescope, that is what he did. And Galileo actually saw these 4, and there's more than 4. What did my slide say, 67? Okay. Galileo looked at the planet Jupiter, and he could actually see these 4 moons orbiting Jupiter, even though there's like 67, but they're only big. We actually, if through a telescope on a given night, look at Jupiter, we'll see these Galilean moons, which is so cool. Saturn, let's see. Oh, I know. So when you think of Saturn, Hannah, what do you think of? It starts with letter R. The rings. That's what I was trying to say. Thank you. Saturn has beautiful rings. I'm going to try to kind of convince you maybe that actually Jupiter, Uranus, and Neptune also have rings. They're just not as cool. All right. So I guess next we have Uranus. Do you happen to know what color Uranus is? It's not orange and reddish. They kind of go in pairs. Uranus and Neptune kind of take on this, starts letter B. They are a blue color. They are bluish. See, what color start letter B? So we kind of have, they go in pairs, okay? Now, let's see. The next one is Neptune. Okay, Neptune is also blue. And I'll kind of ask this collectively to you, Jasmine. So looking at the planets that are after the asteroid belt. Actually, the planets after the asteroid belt, we call these are Jovian, they're gas giants, they're all gaseous. Do they generally have moons? Yeah, they do have moons. They all have moons. And I already kind of told you, even though Saturn, we think of Saturn's rings, actually, they all have rings too. They all have moons and rings. And okay. So next one's Pluto. So what do you think is the blank in here in? Used to be classified as a planet, yep. Used to be classified, I have as the 9th planet. Yep, you got it, for the planet. But we still love Pluto. Pluto's still there. Actually, Pluto had some exciting times with a flyby not that long ago where they got some beautiful pictures. And if you've seen the pictures of Pluto like with a heart, you know, and it really does have a heart feature on it. It's like, really? And anyway. Okay, so let's see, I'm going to show this one. Kuiper Belt, home to comets is the first word. So just a minute ago, I was out here for Pluto, right? Okay, And to get to the Kuiper belt, I'm going to have to go out here. And I can't remember if we had this the other day too. The thing about the Kuiper belt, and this is my question to you, Ashley, is the Kuiper belt is kind of lies in what we call the plane of the, starts with letter E, plane of the ecliptic. That's it, plane of the ecliptic, exactly. So we can kind of think, all this stuff I give here is in our solar system. Our solar system, of course, our sun has the name Sol, so our solar system is our sun system. Okay, so this is all gravitationally connected. Oh, and what I was going to say is the planets and the asteroid belt and Pluto and the Kuiper belt all are kind of on a frisbee, sort of the plane of the ecliptic, kind of plus or minus. Yeah, cool. Oh yeah, there's one more thing called the Oort cloud. So back to you, Kate. What word might go, first off, for the Oort cloud, if this is the Kuiper belt, I've run out of room to show you where the Oort cloud is, because the Oort cloud is like way out here, and it's not just the plane of the ecliptic, it's like a bubble. So that's the Oort cloud. So what is at the center of this mess, Kate? Right, that was the word. At the center of all this mess is the sun. Yep, doing its thing. Doing its thing. Okay, so the formation of our solar system, you can kind of see they're small, but see the numbers 1, 2, 3, 4, 5. Okay, kind of showing you figures of how our solar system came to be. This kind of looks like our solar system. You kind of see the plane of the ecliptic and all that. So a question to you, Hannah. This doesn't have to do this, but what do we call it? And we're going to talk about weather here eventually. But so in weather we talk a lot about gas. It starts with letter C. What do we say when a gas goes to form a liquid? Condensation, exactly. And so kind of along those lines, this theory, and I remember a theory, we talked about the scientific method, and so I'll ask you this in the form of a question, Mackenzie. Is a theory simply a guess? No. What is a theory?
It has to be like proven true over and over.
Yeah, proven true over and over. And all the evidence to date points to that same, in this case, a path to how our solar system was formed. Yep. Now, I'll get out my pen here, and I'm going to, this thing up here, this thing right here, you said condensation. So right up here, I'm going to say that that's a gas cloud. Well, actually, it's right there. So that is a gas cloud. So we know today, my goodness, today we've got, when I think of the planets, well, I shouldn't say that. When I think of the inner planets anyway, before, within the asteroid belt, I think of something I can stand on. They're rocky. So what happens to a liquid if you freeze it? It turns into liquid. That's kind of what we've got. But it started out as gas. So it had to go gas to liquid to solid. The word is contracting. So I missed my opportunity. See, I see gas cloud. One of the things when we look from our planet into outer space, we see our nebula. Nebula. What is that? Well, it's hard to sink your teeth in because it's a nebula. Somebody being nebulous or being like, you can't pin them down. Nebulous. Okay, nebula. Nebula is a gas cloud in outer space. Okay, it just is. So a big nebula actually was what our solar system came from. That was called the solar nebula. Let's see. So step number 2 there, you can kind of see condensation happening. Some of that gas is turning to maybe even liquid or solid. I kind of see some particles there. Can you see a little bit of spin, rotation to that? You can kind of see the arrows at the top and arrows at the bottom. It's actually spinning. It flattens. I don't know how you would guess this word. Well, I know. I'll ask it in the form of a question, Jasmine. Do you know what a prototype is? Like a prototype. If you're playing just jigsaw puzzle or something, you're like, what is a prototype? Like put it in context of, put it in a sentence, like they made this prototype because I don't know why you make a prototype. Prototype is just like the first one, like they roll it out. Yeah, prototype. So, I'm kind of ahead of myself. Sorry, that's nothing to do with this word I uncovered. Sometimes for the vocabulary, I look for words to put on. Sometimes I'll put this word planetesimal, and I'm sorry, I just gotta do this. I gotta put a little heart here, because the word planetesimal, doesn't it just give you a warm spot? Okay, because you were familiar with the word planets. We talked about the 8 planets in our solar system, but a planetesimal, come on. It's a cute little precursor to a planet. It's kind of like a protoplanet. And then planetesimals get bigger and turn into protoplanets. So I've kind of skipped. So we went to 1 to 2, 2 to 3, and 3 to 4. And living here in the Midwest, I'm not going to put you on the spot. I don't know if everybody's lived here in the Midwest all their lives, though. But hopefully you've made a snowball. To me, that's what this totally looks like. Okay? Anybody who not made a snowball? Okay. So the thing is you take it, it gets bigger and bigger and bigger. And I guess I kind of go back to Pluto failed the criteria to clear his or her orbit of debris. Well, it just didn't have enough oomph to go ahead and clear the path as it was making itself bigger and bigger during this process. By the way, which took, I have a time coming up here about 4.6 billion years ago. But I'm thinking this took about 100,000 years or so, 150,000 years. That's how long it takes most stars to do their thing. Okay, so I'll ask this in form of question, Jasmine, since I was terrible with the approach. So, is our sun a star? Yeah. Yes. Very good. And in its center, it has what we call nuclear fusion going on. Let's see, in its core. Okay. And I don't have it up here to describe too much, but I think in here it says, and we'll talk more about the sun. And as we talk about the sun, remember that as the characteristics of our sun actually can be applied to stars. Okay, we'll talk more about stars, but so in the center of our sun actually is where, and we'll kind of talk about why this is, but the matter is coming in, and it's very dense in there. It's very squished together. Okay, and it's also very, very hot. So when it's very squished together and very, very hot, when it says nuclear fusion, basically, so I'll ask this in the form of a question. So, Ian, what element is this?
Hydrogen.
It is hydrogen. So, Ashley, what element is this? Helium. Now, it's more complicated than that, but this is nuclear fusion. Is it 1s or 2? Oh, crap. Oh my goodness. That's nuclear fusion, basically, what our suns do. Okay. One of the things I think is, well, I guess it's coming up on the next slide. Oh, now here, BYA. That does not mean bring your own alcohol or anything. BYA means billions of years ago. So one of the things that I want you to get out out of when we talk about astronomy is timing. So 4.6 billion, I like to think of it this way, years old. So basically our sun is about 4.6 billion years old. Happy birthday. So if you go back, 5 billion years or even 6 billion years ago, yeah, that would be right. 6 billion years ago, I'm not sure where in this process we were, if we had even started yet, but we definitely weren't an entity. All right. Let's see, what's the word? Our orbit, I see the orbit. Condensation theory, we talked about this is the condensation theory, the formation of our solar system. And it's based upon observations including the direction that the planets orbit and, so let's see, where did we leave it? So, Kate, what does rotation mean? Spinning, very good. Rotation is spinning. And if you were to look, I think it's on the slide, look down at the Earth, what direction is it spinning? Counterclockwise, yeah. And most planets are. So just so we're all on the same page here, during this, yeah, thanks. I was like, oh, I hope they showed that right. Can you see where even at the very beginning we had a counterclockwise theme going on? So the planets not only spin counterclockwise, but they also orbit the sun counterclockwise. Now actually I'm going to have to kind of come back, I think, and revisit that. We have two planets that have the whole spin thing screwy. So we had Mercury, Venus. Venus is one of them. If you look at Venus's North Pole, it's spinning clockwise, but we think it got hit. Just if the Earth got hit. And then the other one, if you go out here to Uranus, Uranus is actually, its axis of rotation is, I think I might have mentioned this the other day, it like lies in the plane of the ecliptic. It's like a poor thing. Okay. So kind of a little bit of, I have a couple slides on history. I just think science is so cool how we kind of built on each other. And it's bizarre that it says for centuries, for so long, actually we thought that everything must orbit the Earth. Everything must orbit the Earth, and it kind of makes sense. You figure that wasn't the sun, that was the Earth. And the sun orbited the Earth, the planets orbited the Earth, the stars orbited the Earth. You're like, are you serious? Yes, everything. And that's called actually an Earth-centered or geo meaning like geology is the study of rocks, specifically Earth rocks. So Earth-centered and geocentric model they're both synonymous. They're both synonyms. Okay, so that prevailed for a long time. So Aristotle and Plato were both, and you got to give them credit for looking at their observations and making a model that fits their observations, right? And there actually was a struggle, and we're going to see this with Galileo, or we see this with Galileo, between science and the Catholic Church or faith. In the case of, it was specifically the Catholic Church in the case of Galileo. So one of the things, when we finally start to kind of get away from the Earth being, like everything orbiting the Earth, we're going to see that we had to make a leap from things being perfect in the sense that even the shape was perfect, like a circle is perfect, and an oval is imperfect. You're like, are you serious? I'm like, yeah. So, right. Now actually, I've got a couple little videos to show you this. I'm going to do my slide and then kind of see if the videos help make more sense of it. That red thing there, that red orb, okay, that is actually the planet Mars. So you can kind of see, I'm going to dim the lights a little bit. So you can kind of see Mars go from June over here to July to August, September to November. Now I can see them better. And you can see these little pinpoints of light. Those are actually what we call the background stars. So those stars are not in our solar system, obviously. Where one of the things I forget to mention sometimes, and we'll talk more about it, is those stars are in our Milky Way galaxy, but they're not in our solar system. So we see, let's see, what's the word there? Eastward is the word there. Usually, to me it looks westward, but I'll have to go with eastward. I didn't have time to chase it down. But the planet, not in a given night, but night after night after night, so that's why you can kind of see months here. When it goes this way, okay, that's what we call direct motion. Okay? So this would be direct motion. When it backtracks, like it's doing from July to August to September, this guy right here, this sweep, I'll put a little star here. This is indirect motion. Indirect motion is the way I learned it, and here we call it retrograde motion. Indirect motion is equal to retrograde. Retro means rebel. Now, stars don't do this. Stars don't wiggle, okay? But planets will wander against the background stars. And I hope this makes sense. Let's see. If I make this chair, this is still the sun, right? And I'll make that chair Mars, okay? One of the things actually we're going to see that Kepler found out is that if you're closer to the sun, you move faster. You move faster, and I kind of almost think it's like you have more of an assist, a gravitational assist. So you move faster. So Mars is moving more slowly. So can you almost see where right now I look at Mars and I see it against background stars over there? Okay, I go over here, I don't know, maybe a month later, maybe a week later, and now I see Mars against these background stars, different background stars. So I'm getting that, the whole wonder thing. I want to show you these couple things, these couple videos to try to show you, let's see if I had something else up here. The word is explain here. I want to try to show you why we get this retrograde motion or indirect motion. By the way, if you're into, which I don't encourage or discourage, it's just not a science. If you're into astrology, okay, they will actually kind of talk about the planets and where they are, what house they're in, and if they're going retrograde. That's like an astrology thing. Okay, it's a science thing, but they kind of incorporate it into there. So let's see what we think.